so this is going to be our first kind of series test that we are going to be looking at. And the series that you will use telescoping on is going to be one that mirrors partial fraction decomposition, okay? So if I wanted to figure out if this series converges or diverges, the first thing I look at is, do my terms end up going to zero? So just the limit of your sequence of these. And yes, that goes to zero. So now let's look at the partial sums. So S1 is going to be 1 over 1 times 2. So that's going to be 1/2. S2 is going to be 1/2 plus 1 over 2 times 3. S3 is going to be 1/2 plus 1/6 plus, we do 1 over, it's our third term, 3 plus 4, so 1/12. And we could keep going on over and over and over again with this and try to figure out what this limit is. But another way you can look at this is we can do partial fraction decomposition. And when I do that, if n is -1, I get that b is -1. And if n is 0, I get that a is 1. And so I'm really looking at this series, and this is a partial sum that might make a little bit more sense to look at. Okay, so if I were to, instead of, or not partial sum, we're actually going to look at the full thing, okay? So if I were to do this, I would end up doing 1 minus, here, I'm actually going to write it down here because I think I need a little bit more room. So I'm going to do this full sum. So my first sum is 1 minus 1/2. But then when I plug in for my second part of my series, I get 1/2 minus 1/3. And then when I plug in n equals 3, I get 1/3 minus 1/4. And so notice these sums end up always canceling out. And so your sum is actually just going to be 1. Like all of these are going to end up having a partner that cancels out. And if you look at the limit, as n goes to infinity of these SNs, you will end up getting 1. Okay? All right, let's look at another one. So I look at this, I could look at partial sums, but I'm noticing it's a partial fraction decomposition. So I actually want to look at the overall sums, and I'm going to split this up. Okay, if n is 0, then a is 3/2. If n is -2, then b is -3/2. And so I'm looking at 3/2 over n minus 3/2 over n plus 2. All right, let's go ahead and list these out and see which ones cancel. So when I have 1, I end up having 3/2 minus 3/2 over 3. Plus 3/2 over 2 minus 3/2 over 4. Now when I plug in 3, I end up having 3/2 over 3 minus 3/2 over 5. So now you'll start to see like, okay, that's where my cancellation is going to start happening. My next one's going to be the 4, and then I'll have the 5 gone. And so the only terms that will end up being left are these front 2 terms. So that's 3 halves plus 3 halves divided by 2 is the same as multiplying by a half. So that's 3 halves plus 3 fourths. 3 halves is 6 fourths. So 9 fourths is my sum. All right, everybody's favorite. Let's do this with some trig. All right, if I need to figure out the cosine of 1, we'll leave that alone, minus the cosine of 1/2. And then I need to add into that, plug in 2, the cosine of 1/2 minus the cosine of 1/3. And these would all be in radians. Okay, plus, when I plug in 3, cosine of 1/3 minus cosine of 1/4. Those cancel, those cancel. This is going to end up canceling all the way down into the end because it never ends. And so this sum is the cosine of 1 radian.